Okay, so welcome to GraphQL and GraphDefinition. Okay, so before I get started, how many people here have used GraphQL? Not bad. How many people have used GraphDefinition? Yeah, that's what I thought. That's okay. Okay, so I'm going to try and see if I can run those numbers up. Although they solve very different problems that are only conceptually overlapping. So both GraphQL and GraphDefinition are concerned with scanning across the content of resources. GraphQL is a simple use case that should be of interest to everybody to return a subset of information across a graph of resources. The return content that you get back is not actually resources. It's just pure JSON. GraphDefinition specifies a set of rules about the relationship between resources, and you may use that, among other things, to return a set of resources, a bundle. So they're quite different in both the kinds of people who use them, the reasons you use them, and the outcomes from using them. So first of all, I'm going to concern myself with GraphQL. So it's a pretty easy problem statement. FHIR provides you with a well-designed, very modular set of schemas and CRUD operations on said resources based on schema. And you run a client API against you create a client application against the API. Your user interfaces will require sets of resources. For instance, say you want to show a list of encounters. You're going to get a list of encounters. For each encounter, you're going to fetch the patient resource for the encounter so you can display the name of the patient. For each encounter, you'll fetch the consulting physician, the ward location, and so forth to get each of those things. And you'll do that for almost every list that you show in the application. And that's plenty of work. So you can, in order to minimize the amount of work you do, you can fetch the encounters, you can iterate across the encounters fetching all the related resources, and you can cache up a local copy so that you don't have to keep going and fetching the resources. Because you could be building a pretty big cache as you scan across a clinical record or set of clinical records. And so the price is you get bandwidth, latency for each n resources you have to fetch, and you have to manage the cache. Alternatively, you could fetch the encounters and ask the server to include in each set of encounters that comes down the relevant resources that you need. And so that's a facility we included for this use case very early in the FHIR lifecycle. So you can say to the server, send me the encounter and all the related patients and provided practitioners and locations and so forth. And then you'll get a big fat bundle that will include all of the lookups that you need to be able to do to display the list. So the price for that is the bandwidth goes up, but you only have one piece of latency for each page of results. And so your latency goes down, and you don't have to manage any cache because you're just getting them on the fly. But your bandwidth has actually gone up. So you didn't really save that much by using include. Ideally, you would say, well, I'm only going to fetch the bits of the resource that I'm going to display. And for each of the things that I need to look up to display related things, I want the server to do that for me and then return me just the things that I want from those other resources. And I want the server just to handle it all for me. And then I don't have to do any work on the client. Bandwidth goes right down, latency goes down. I don't have any cache to manage. I just get exactly the data I need for any particular use case. It's pretty straightforward, really. And just about everybody who's running a client faces this problem. This is where GraphQL enters. So GraphQL is that language that you use to tell the server what it is that you want the server to return it. You can query against the graph of all the resources the server owns and be very, very selective about what it is that you want to come back, and you get just what you want returned. So let's have a look at a really simple example. Here I have a request for a patient example. You can run this yourself if you want against the test.fire.org. I noticed when I was playing with it this morning, someone's deleted the example patient in R3. I don't know why, someone has, but there were R4 ones still there. And so I'm saying, instead of sending me back the example as a whole, I want you to run this GraphQL query against the resource. And here's the GraphQL blown out into a human readable form. I want you to return the name, any name, and for each name, the text, the given, and the family field. So this is the language specification specified in GraphQL, which originated in Facebook, and is now an open specification, not yet an open standard, but they've made it an open specification. The result of running this query is that the server digs up the example patient, looks for the name, any fields. The only field you've asked for is name, so it only returns the name, and then it returns those 3 fields in the name. So here's what comes back. A GraphQL response, which includes a data element, which is the data returned by the query. You might alternatively get an error. I'm not going to show any of the errors, but there's a way to return errors. So in this case, you ask for the name, so you get an array of names, since it's an array in the underlying JSON, the given and the family, and apparently there's no text on these names in this original, in the example patient resource, since I copied and pasted this off the query yesterday. Now, having said that, someone's going to go ahead and add text to the patient example just to confuse everybody. Okay, so you get back the given names, the family name, given names, family names. And that's all you get back because that's all you asked for. So it's a pretty straightforward language with a whole specification for the language that describes how you query to walk through the resource. Of course, and when it comes to polymorphic fields, value quantity, this would be an observation with a value of 185 and a unit that comes back. Before I get into that, so the idea is that it's the simplest possible way just to iterate through this graph, getting only what you want. Once you hit fields that are repeating fields, you can start getting clever. And we did a little bit of adaptation of the basic GraphQL concept of FHIR. So you can say for a list, you can say return only the elements for this FHIR pass statement that's true, or named values that have to be true, and you can also iterate through the list. So if the list is really long, you can say only give me the first 20 results. So let's have a look at an example. I want a name. I only want names where the use is official. I just want the official name. Don't give me any of the other names. In the text, give me text given in family. And if you find an extension with the URL of a nominated URL, I didn't care what it was for the example, then give me back the value that's the string. And in fact, here I actually renamed the value. This is the value string in JSON. I said, I just want it named value. So what you get back is only the official name and my extension with value. So if you know what extensions you want, you can rename the extensions while you do it. Make it easy for the client. All right, by the way, you can feel free to ask questions as I'm going if you want to ask questions. I didn't say, David.
Ask for all extensions?
Well, yeah, you just say extension and you'll get all the extensions. Was there another question, yeah?
Have you back up a couple slides? I'm curious why you rooted GraphQL query after retrieving the patient record versus at base/GraphQL.
I'll come back to, you can do it at either place. I'll come back to doing it at the base later. I just wanted to introduce the idea slowly. Any other questions? Okay, by the way, there is a page for this, which most of these examples come off a GraphQL page in the specification from the documentation page. And unlike a lot of the rest of the specification, the GraphQL page includes live demos against the server. So when I got here, this is a copy paste out of the spec, and you can actually click on this in the spec and go and run it live against test.fire.org. Of course, since anybody can do whatever they want with the data in test.fire.org, the outcomes are somewhat unpredictable. Okay, but you can also say, I want to return a name where the FHIR family.exists is true. And so in this case, I will only get names returned that have a family. And so you can start to get pretty clever with what's returned. When you hit a reference, this is where it gets useful, there's an implicit field resource, which is in every reference, which is the target of the reference. So you can say, well, I want to walk into the resource and return what's referred. And actually, you need to say what kind of resource it is. It's a GraphQL thing. You have to know what you're dealing with. So here's an example of this. Here I've got a subject. This is an observation, let's say. I've got a subject, and I want to say, if the subject is a patient, then give me the birth date on the patient. And by the way, give me the code. So you get the code part, that's out of the observation. But when you get subject, instead of getting a reference to a resource, you walked into the resource, say the resource for the subject has a birth date of, and that's the birth date. I think this is out of the observation example in the spec. So that's how you walk across the joins to the resources and just keep walking, and you can just keep doing that. And you can actually go backwards. You can search on reverse references, and then, so you can walk backwards through the graph. So this is going to be you'll be doing it with a list of resources here. I want to have a list of resources. Either I'm going to query the root of the server, so I'm just interested in everything, or I'm interested in all the resources that refer to this, but the language is the same. So you do this by search parameter. And so the search parameters you already know using search. And there's two forms of doing this. One form is simple, and it meets almost everybody's requirements, and it has no load on the server to implement it, or no particular load on the server. It just has to evaluate the queries. So whereas there's a complex one with a connection which has cursors, the server has to remember the cursors. It's kind of a bit of a nightmare, actually. But it's part of the GraphQL spec, and really, really super sophisticated clients might decide they want to do it. Although, man, I could tell you can get in a mess doing this. So let's look at the simple example, and here we're going to query against the system itself. So that's the one you were asking about before. The query against the base of the system, just run this GraphQL query. I want to have patients. In this case, I'm going to specify the ID of the patient. We didn't really achieve anything in this case. We said we just want one patient, the example patient, and give me, well, we're already talking about that, the ID and active. Oh, I've got these two inconsistent. That was well done me. But in this case, your ID and active, and you'll get back the patient, ID and active. But you can go for something more. See, let's do a condition list in this case. I want you to give me a list of the conditions for this patient that have a status of relapse, and give me the ID and the clinical status. I mean, in reality, you'd ask for more fields, but only so much screen space to play with. So I'll get back a condition list, a list of conditions, and that's just the list of condition resources that met that query. All right, so that's pretty straightforward. Or I can put a FHIR path here or whatever, and that'll just apply to whatever the search query returns. And here's the connection. This is the sophisticated query part. So I say I want a connection to a list of conditions which have a clinical status of active for this particular patient. I want you to return the count and the offset and the page size. And then for each of the edges, I want you to give me the search mode and the search score, and then the resource. And so now finally we hit the resource. We're 2 levels in before we hit the resource. And I want you to give me references to the rest of the searches in here. And so condition, I found 50 conditions. This is the first page. I'm going to give you 25 in the page. This is the link to the next, and here's an edge with a resource, and away we go. So you're actually doing a full search. You want to get in a mess, walk through a few graph links, a few references. So you have 4 references in, and throw one of these in, and then inside that throw another one in. You've got nested cursors. You're in a mess. My server will faithfully record the cursors, but you might get very unexpected results if you jump into one of the inner cursors without going through the outer cursors, because you don't even know what the context is. I remember the context. It's kind of a bit of a mess, but it falls out of the GraphQL specification. So my advice is leave that one as long as you can, and just stick with the simple lists where you say, I just want a list, and I'll get the whole list. I don't want any cursors. Cursors are hard. Okay. All right. So that allows you to say, hey, I'm going to go from my patient to my managing practitioner. Then I'm going to search for all the observations made by the managing practitioner. Maybe that's not a very good example in practice. But then I'm going to go and find off all the provenance resources that refer to those observations. And you notice I'm navigating the links backwards and selecting which ones I want to see. I can actually query an entire medical record like this. There's one restriction in GraphQL. There's no wildcard query at any point. That's just part of GraphQL. You have to name every field. You can't just say, and whatever, at any point. Right? You will keep naming fields. And so here, for instance, I think I admitted any copy. No, I did have one back here. So you can't just say whatever. You have to say, for patient, do this. For group, do this. For whatever, right? So you have to always be extremely explicit when you're doing GraphQL. You can never just get to the point of, I got to the point, I wanted now to give me everything else. There's no everything else. Yeah, Christian.
Yes, the first example you queried by ID, but you didn't use the normal underscore ID search.
Where was that? That was here. It was here. Because you feel that's a very good question. I'll answer you on Julep later. I'll have to check. I have to check because sometimes you're dealing with search parameters and sometimes you're dealing with fields. I have to go back and check the documentation carefully. It might be a search parameter. I have to check. So good question. All right. Then we get into advanced stuff. So it's probably a good time for me to take up a question. Is this more work for the server? Well, that's a tricky answer. If the client says, hey, I want all this data, I will just iterate through the data doing all my queries, then you're going to do the same amount of work doing the queries as a server, but you'll return more data. So actually this saves the server work. Yeah, you'll buy that. On the other hand, once you get into this client doing GraphQL, it's kind of easy just to keep walking stuff. That's why Facebook didn't put the wildcard in. So there's no walking the wildcard. You still have to actually say what you want to walk, but you can walk stuff much more easily. So it's reasonable to say, I think the server might end up doing a bit more work this way. So it's kind of a bit balanced. But from the client's point of view, this is really, really straightforward. If you can query the data this way, why would you not do that? I'll come back to that shortly. Not this way. Don't do this way. Okay, all right. Now it gets more useful. And I'm only going to brush across this really quickly. All of you know that every resource includes capacity for requirements that you don't deal with. Fields that don't repeat for you. Fields that are deeply nested because if some requirement that is not your requirement, but you still have to walk through the nesting. Well, with GraphQL, you don't have to. Here's a case where we say, you know what? I know there's only going to be one identifier, so just flatten out the identifier. I don't have to walk into the identifier. And the name the same. I don't have to walk into the name, just flatten it. So instead of having identifier containing a system and a value, a name containing a given and a family, then I just collapse them all together. So I didn't have to walk into those nodes. David?
What if there's more than one identifier?
Then that's what happens here. Family became an array because you conflated a thing that was an array with two singletons into an array. Yep, that's why I put that example there. So I mean, it's not great yet, but it might be helpful. Yeah.
I guess the flattening is only useful as long as you don't care about the relationships that you're losing once you flatten.
Well, yes, you would not flatten if you cared about the relationships. You would flatten at the point where the relationships are not of interest to you and are not encountered by you, which is relatively common for most clients. For instance, you're dealing with an EHR that only has space for one name. It's a dumb EHR, but I've seen plenty of them. So, flatten them, yeah.
Graham, what's the real reason for this flattening?
Aha, because at this point, I was doing some data analytics work in R, the language R, and R is automatically bound to the structure of the data source. And R as a data analytics language really likes square data sets. And this turns out to be a really convenient way to square things up. I haven't finished yet.
Should we introduce this into FHIR?
No. No, this is where you should do this. If you want to do this flattening, do it here. Actually, but you can do more because then you can say, actually, I'm going to tell which identifier I want you to flatten. So you can do that. Or I can say, actually, I want you to split identifier up and rename the different elements so I get usual identifier and dot system and casual identifier dot system and so forth. So there's a number of things you can do. I didn't go into them all here in the spec, but you have plenty of choices for restructuring the data as the server processes it so that you can move data towards a square structure that makes it easier for data analytics languages. And if you're doing R or Python purely for analytics and you want to throw the data straight into some kind of graphing library or some kind of data analysis library, that's when this technique gets particularly useful. So where are we with GraphQL? It's a really powerful tool for a client to reshape the data, to shape and reshape the data for their own purposes. And the restructuring might be particularly relevant when you're going to pass data on. So far, GraphQL is supported by test.fire.org and Happy, and Asymmetric have an implementation as well, but most of the other servers don't do that. I asked Christian why Vonk doesn't support it, and you know what he said? Nobody asked. And I'm like,
Support it in the next version.
sorry?
Inbox will support it in 1 week.
Very good. But given all that I've shown you of all the things you can do here with GraphQL, why has nobody asked? In fact, so a little bit of history here. 2 years ago, last month, Ewout and I went kayaking in Norway. And on the way back, we had this long discussion about where we are with a feature set. And Ewout said to me, we got to look at GraphQL. So I went home and looked at GraphQL and worked up all this stuff and wrote it and put it in my server and then said to everybody, hey, it's a really good idea. And everyone said, yeah, that's a really good idea. And then just left it at that. I think that it would be useful for us to bit more focus on GraphQL. It's a really powerful technique that's really good for app developers. Of course, yes, you need to parse. You need to basically have a little engine that parses the GraphQL and sits in front of your API and basically just proxies the API on behalf of the client as guided by the GraphQL creating and returning JSON back to the client. So you just put it in front of your existing API. You don't have to do anything inside the API. We didn't write any facilities to ask the API to do anything different than it already does. So you're just remoting a set of things you might do on the client side. So, so you could also write, someone enterprising person here could write a GraphQL facade for a real server. It's probably not as efficient as doing it inside the server, but you could still do that. That's my way of encouraging people to take up GraphQL. I'm about to move on to graph definition. Oh, there's one thing I was going to say. In GraphQL, they talk about mutations, ways to change the underlying resources. As far as I'm concerned, as far as I can see, there's absolutely no benefit to a GraphQL mutation over just a straight put or a post to the underlying resource, so I didn't bother doing anything with it. If you can do that, just do that. I'm open to discussion on that. Published GraphQL schema, there's some discussion on Julep about getting some corner issues nailed down in that. It turns out that there's no schema MIME type for the GraphQL schema, which is kind of cool. All right, any questions about GraphQL? Yeah.
Could you explain a little bit where the difference between GraphQL and FHIR?
So GraphQL is a language that sits in front of the RESTful API and lets you plow through the RESTful API doing actions on behalf of the client. FHIR is a query language that's querying over the resource itself. It doesn't cross references, well it can, but it's a query language on an object structure rather than on an API.
But I can take the results from the API and apply FHIR.
Yeah, and in fact we added the ability to do FHIR inside the GraphQL on a set of resources you got from the query or a set of objects you got from the query and run FHIR. That's an optional part of the spec, that part. But they do different things. FHIR is more of a classic query language, whereas GraphQL is technically a graph production language rather than a query language.
So it doesn't support predicates, is that what you're saying?
Only through FHIR. Any other questions? Yeah.
Is there any open source to help translate the query into the API?
Well, the implementation that I did for test.fire.org and for Happy are both open source. In as much as you would find that useful, you're welcome to use. But I mean, I wrote a parser, an object model, then I wrote an engine that takes the object model and an API handle and creates JSON objects against the API. If that is the same kind of model you would be taking up, if you use Java, you can just use that code directly. Otherwise, you can use that as a pattern to copy from. There's plenty of open source GraphQL generally in a wider context anyway, so maybe some of that's useful or more useful for a particular use case. I'm not sure. Apollo in particular, all the GraphQL people focus on that.
Yeah, do you know if anyone actually has put this in production? Any course or commercial tools someone putting? I'm just concerned about or interest about the performance on the GraphQL.
GitHub deployed for production. Facebook and GitHub.
Well, I mean, outside FHIR, yes, there's lots and lots of production. But in terms of performance, the GraphQL language is really, really simple. Parsing it is really, really quick. There's absolutely no look ahead in parsing the language. Actually, interpreting a language is simple. You're running the queries inside the server framework, so there's no latency between you and the API. It's way faster than alternatives. Okay, it might be more load on the server net because it's better, the server becomes more effective for the customer. But it's way faster than any alternative I know of.
Faster than clients hammering your server, getting
Yeah, much faster than clients doing it, yes. Much less auditing too.
But for most of implementation, there is an
well, I mean, the client would be doing that anyway. I got to say that I went to a HTTP conference and Mark Nottingham, who's the community lead for HTTP, was sounding off about GraphQL because GraphQL makes it impossible to cache the results. You can make of that what you want.
Oh, did you say that you can span across resources?
Yeah. That was how we showed that one back here. Where here we started with an observation as a subject, which refers to a patient, and then we just walked through the resource that the subject references and into the patient and got the birth date of the patient. So then we started with the observation. The subject has a birth date of X. So we walked straight across the boundary there from observation to patient. Okay. In the spec, they say that you can apply GraphQL to XML or whatever. Well, I didn't bother with that. We described how to use GraphQL against FHIR resources. There really wasn't that much for us to say because we're actually just using a language geared for JSON against JSON. All right, moving on to graph definition. Graph definition is a bit more difficult as an idea. It has a different set of uses. So you're all familiar with the definitions of the resources, and most of you would be familiar with profiles, a set of rules about what's inside a resource. But what if you wanted to make a set of rules about relationships between resources? Let's say, for example, to quote someone who came to me, I'm really, really bothered by FHIR. It's a problem because you can't promise me that an observation that has an encounter, I want you to promise that the encounter refers to the same subject that the observation refers to as a subject. That makes sense? If an observation has an encounter, both the encounter and the observation should have the same subject. Is that always true? No. Is it true 99.9% of the time? Yes. Does it matter? Yes. So we can't make that rule in the spec, but most of the time it matters. How would you say that it matters? How would you ask the server, is it true? Is this set of data, does it meet my business rules for data integrity? How do I say that you can't cross patient compartment in this set of data, which is a set of observations made on a patient at a particular time? Or alternatively, if you have any experience with documents, you know that FHIR has a way to specify that to ask, given a composition, you know, ask the server to turn it into a document. Package up everything, put it in a document, sign it, give it back to the client. It's now a portable pack. And one of the things that the operation that does that, it says it's to the server's discretion how much supporting data to put inside the document. Well, what if you want to give the server some guidance? You're talking about a set of relationships between resources, a graph of resources. So this is what graph definition does. It defines a definition of a set of resources based on the relationship between the resources. We're not interested in what's inside the resources. We just treat them as opaque nodes. We're interested in the relationships across a set of resources. We start at a fixed starting point and define a nested series of links. So we say, take the case I talked about, observation. An observation has an encounter. An observation has a subject. Encounter has a subject. We will walk through all those links talking about the rules between them. So it defines what the links that we're interested in are, the cardinality rules on the links. We can cross links forwards or backwards, just like with GraphQL. So we can say, we want to make rules about the observation and all the provenances that point at the observation. We can talk about the target types and the profiles that apply to the resources. And we can make rules about the compartment consistency. This set of resources, for this clinical case, must all have the same set of author. The author must be the same in all of them. Or the patient must be the same in all of them. So it's a way of saying things like that. So here's an example. We're going to have a patient. We want to make a rule, and so the patient, which is a US core patient, will maybe have a managing organisation, a cardinality of 0 to 1. And if it does, it's going to be an organisation that may have an endpoint. So we've described that part that we're interested in. We didn't make any rules about this. We just said that we're interested in that. Or if it's a group, it might have an item which is a patient. We're interested in, that's the size of the graph that we're interested in. Patient also has a general practitioner, which is an organisation. And we will search for the observations that relate to the patient, and we'll be interested in the first 10 of them if we find any, and they will have the same practitioner and also we'll get any members and derived froms in the observation. That's actually an R3 based rule. So this is a bit hard to grasp, but we're saying that we're interested in the set of relationships that start from the patient. And we've made some rules here. Some of the things we talked about, we just said these links exist. We didn't make any rules about them. Others we did. So what can we do with something like this? I'm not going to talk more about the language for time reasons. So one thing you could do is actually just use it for documentation. And we've written some implementation guides where people are really interested in the relationships between the resources. You know, with you dealing with US core, or you're dealing with, say, QI core, you're saying, I'm interested in a condition that has these rules. But if you start moving to really use case-based stuff, and say you start talking about, well, IPS, the International Patient Summary, is a document. How do you describe the document? You can write a bunch of narrative, but how do you actually describe the content? That's where you would be describing this. Of course, starting from patient, we're not describing a document. Or you could say, define a graph of resources to return in a query. And so do you do that with a syntax to say, for this medication dispense example, get me that. And by the way, while you're at it, chase down everything in the graph, this graph, and give me all of that. So let's see how that works. So I looked up the patient example and said, give me this graph. So the server would go, okay, I'm going to give you the patient. And the manager organisation points you at the organisation. I'm going to give you the organisation. And I'm going to give you the endpoint that the organisation points to as its endpoint. And because it's an organisation. And I'll give you the general practitioner organisation as well. And also I'll do this search on observations and return those observations and their performers and their members and derived from targets. So instead of having to chase all those things down, this is where it overlaps with GraphQL. I said, this is the set of stuff that I'm concerned with. I don't have to tell you about the stuff inside the resources. Just give me whatever's inside the resources, but walk across all these resources and give it back to me in one big bundle. So that's the point of mentioning these without making any rules about them. It means that I can just ask the server to walk across all of them and return them to me in one big bundle. Or I could use this with a different one that starts at a composition and say this is a set of relationships to chase down while you're building this document. And then, oops, also I can say, I can go to a particular resource and say, hey, resource, do you meet this set of rules, and give you a bunch of rules? This graph definition example doesn't actually say very many rules, so it would be incredibly useless to ask, is this valid against this set of rules, since there is no rules here? But if I said that this was one-to-one, then, and I picked a particular patient, I could say, well, it has to have a managing organisation. And then I could say, and the organisation has to have an endpoint if I put one-to-one there as well. And this operation here would return false if the rules as a collective group were not met. Okay. All right. So graph definition is over the horizon for most users. I bet most people in this room are going, yeah, it doesn't really look very interesting to me, but there'll be a few people in the room going, gee, that was really cool. I've been wanting something like that. So, but for most people, it's over the horizon. I'm pretty sure my server is the only server that supports any of that. Ha! There's always one.
Is there any consideration
Well, you can define rules about compartments, not defining compartments. Could we define the existing compartments?
It's all the relationships.
Well, but the compartments aren't built by the relationships. It would, at best, be an imprecise representation since it can be established by extensions. Well, I don't understand. Clarify.
Because the subscription, I want to get the changes to stuff within that graph.
I think we should walk before we turn into jet engines. Yeah.
Yeah. Oh, by the way, before you start worrying, during that long Norwegian trip, we also looked outside the window and admired the Norwegian landscape.
The Norwegian landscape was particularly awesome to admire.
I wonder, did we discuss running these graph definitions on not a single resource, but on search result? I don't remember.
Search result.
Yeah, because sometimes you do want to do a FHIR search and you say, but for every instance in the result column, we'll actually want to have a whole, so like a mega include.
That'd be awesome.
Yeah, it would be, but I can't remember whether we discussed it.
We never discussed it. I never wrote it up. I never implemented it. Make a task.
Okay.
And you guys can implement it as well.
This time, instead of bringing it up on you.
Yeah. All right. Any other questions? Yeah.
For the document, you can describe the references, but in a document you've also got sections, specific sections.
So the rules for a document are that the document must include any resources explicitly referenced from a section. You're interested in beyond that. It's to the server's discretion what else that those resources refer to go in the document or not. And that's where GraphDefinition gets involved.
But it wouldn't say what are the sections.
No, it starts outside, that's inside the first resource. And it's only interested in outside the first resource. The document people are very interested in this. This is the first place that actually went into connectathon usage. All right. Any other questions?
Well, I just can give you one more reason why this is going to be more interesting even than, the GraphQL I think is a client-defined query, right? And we discovered that when we were translating V3 messages to FHIR, people had to find a server, so a server-defined set of data that you need to return. So we find that GraphDefinition, the fact that you can define server-side a GraphDefinition that mimics that was very useful as well. So that's another use, I think. Where the granularity of FHIR is not the same as some existing data set that you had defined, you can actually formalize that data set again in GraphDefinition and say, now give me the data using the GraphDefinition.
And so you'll see, although the specification says that you can inline this in the URL, in all my examples I've assumed that you have pre-packaged, pre-described, pre-agreed graph definitions that the system already understands, whereas there's no such arrangement with GraphQL. With GraphQL, you're always passing it. There's not a lot of point in having a set of styles, pre-existing, limited agreements between client and server.
Right, so to make sure it's sufficient in serving that data set. And
Yeah.
Yeah.
Christian?
It looks like you're referring to the graph with its ID.
I am.
If you want to coordinate that or have static ones, would it be logical to do canonical for that?
Yeah, you can put the canonical in there instead. Okay, any other questions?
So are these graph definitions something you document in your profile?
Uh,
Just provide them as definitions?
yeah, well, you document them in your implementation guide or your system documentation somewhere, yeah.
Do you think a graph database is probably the future for storing the files of?
I don't think that any of this makes any difference to whether you do or don't store in a graph database as opposed to a relational database. They're all things that sit in front of your API, and
I get that. I was trying to say whether you see it to be a candidate that instead of storing the relational, the way the data is structured will better perform if we start using it.
I'm on the record as saying that I believe the best database approach is a combination with a graph database of some kind or other and a relational database of some kind or other, and you trade between the two. I won't be drawn any further than that. All right, that's it. Do go and hassle your favourite or unfavourite, as the case may be, server provider and ask them where GraphQL is. Thank you very much.